A complete test data solution for DB2. So this is quite a detailed demo, so feel free to move forwards and backwards through it. Here is a rough agenda of what we'll be covering: scanning, building a data catalog, creating lots of synthetic data using different methods, subsetting, masking, modeling variations, self-service portals, federated data, and the like. So let's just set the scene a little bit. So this is all about improving DB2 development and testing. So we provide a complete system to support DB2 developers and testers. We have lots of AI-driven accelerators, and initially we do a lot of deep scanning to understand your data, which can then obviously feed into your AI accelerators. You would use this for regulatory support and governance, making sure that no commercially sensitive data or private data ends up in development. We allow you to design the correct data that matches with your test, and we can do that by modeling the requirements and modeling the variations of the data required during testing. We can find and reserve data so that you don't get cannibalization and one test stepping on other tests. And we have a lot of environment management tools which allow you to compare, snapshot, and roll back data. Basically everything we needed to support developers, giving them the right data at the right time. So this is the platform. We have lots of different components which of course all interact. At the heart of it, we've got a metadata catalog or data catalog, and that basically captures all of the information about the structures, the contents, the keys, the relationships, etc. And then there are various components that interact with that to provide the data that you need. So here we have a DB2 system, quite straightforward. We've got some customers, orders, products, etc. We also have the ability to have local accounts, transactions, passing money in and out of the accounts to pay for your orders. So here is our data catalog, our data dictionary, and let's go and have a look at DB2. And you'll see what we've done is we have pulled in the structures with all of the various different columns, like so. You'll also see that we have documented them. And if you go to our AI assistant, we have lots of powerful AI tools. We can scan the data, look at the PII, etc. But we can also group the data. We can add in descriptions and the like. So here's all the details about the tables. We also keep track of all the various different versions associated with it. So let's have a look at those versions in more detail. We'll see the various different versions. We can also see what's happened to the tables. So if we compare version 1 with version 5, we compare the structures to see what tables and columns have been added. Here you can see we've added a few extra columns to a couple of the tables. We also keep track of all the relationships, and we have various different diagramming tools. Let's look at the first one, which is entity relationship diagrams. And here you will see the relationships. We've also grouped the tables automatically using AI. We also display the relationships between the tables. These are a mixture of discovered foreign keys, which you get from the metadata catalog, and we will also scan the data and add in any business relationships which we've identified by looking for common keys and patterns, thereby producing a much more accurate description of how the tables and columns are related. So now I'll show you how we do some of that scanning. We've set up some data activities, one called bank scan, and then there's another one called validate bank. Let's look at the scan first. And what we have here is some very, very deep scanning, where we will scan the data looking for categorization, tags, PII data, etc. We'll also go and do a deep learning analysis of the data, looking for univariate and multivariate relationships between columns within and across tables. And if we're going to have a look at the validate, what we can do there is look for potential relationships, which is what I talked about before. And we can also run a validate to validate the data for data quality issues as well. So let's submit the validation. And here we're just pointing it at the database we were looking at before. We fire that off, and in a couple of minutes that job will finish. Let's just go and have a look. And it will produce a very detailed report telling you the number of rows it's checked and any errors. And here you can see we have actually got some errors inside our development database. And this is because the IBAN numbers don't match between the accounts and the orders. Now, when you do get validation errors, this can be for multiple reasons. One is you've got the relationships wrong. Secondly, you have actual bad data, and that could be because the application is wrong, or in this particular case, what's happened is we haven't synchronized up the latest IBAN numbers into the accounts table. So now let's get into using our test data activities. Now we have lots and lots of different types of activities depending on what you want to do to support development and testing. The one we're going to focus on initially is data generation. So at the heart of synthetic data generation are generation rule sets. Now these are built up from the data definitions, which we've looked at, and the deep scanning, and that then roll up into a generation rule set. So let's go and take a look at one. So this is a generation rule set. Very simple in this case. We've added contacts, accounts, and bank transactions, and within that we have added in the various sets of instructions and parameterization that we need to create the data that we want. Now we have lots of time-saving features to help you build these synthetic data instruction sets. Initially, we have the defaults, and these defaults have come from the scan. Once you've got the defaults, you can quickly go in and start manually creating instructions yourself using our data painter. But also we have the ability to pick up information from prior generation rule sets that have been created by others. We have lots of accelerators for the most common types of synthetic data instruction sets you need. We obviously use AI extensively to build these instruction sets, and you can also very simply just extract some nice sample data, some of your favorite orders, customers, etc., and use these as the basis of the data that you want to create. Once you've done this, we create a set of forms for you to submit your data requests. We can also build models of variations of the parameters. You can invoke the synthetic data in our data pipelines, and we also have an API layer which allows you to create the data from your automation scripts or any of your DevOps pipelines. Another very useful technique is to take some existing data, maybe you want to take a supplier and all of its core information, and create another version of that supplier. So we call this cloning, and we will automatically create you a generation rule set to do this, where we extract the specific supplier. We will assign any new IDs, so all of the primary keys, foreign keys, internal identifiers are handled by us. You can, if you want, enhance that data, which is very common. You could parameterize it, and if you want many copies of that supplier, you can also explode it. All of this can be taken from one environment to another, or you could potentially use it inside your development database to create more copies of the same data. Now, once you have your generation rule set created and you have the ability to create scenarios, you can then move on to using our data modeling tool and our complex data creation engine. Now, what we're doing here is we're basically building up variations of data to cover more scenarios automatically. And these, in effect, should match with your requirements, whether that be for positive or negative testing. We can also use techniques like constrained combinatorial variations to build the data, and we can also use AI to build you up the variations of data that you require. Now, once we've built up these models of the variations, we then use that to create all sorts of variations of data automatically into your environments. You can use this technique to certify that your application is working correctly. You can use it, for example, to make sure your validation is working by throwing all sorts of different variations of bad data at it. And for messages in particular, you can create all the different variations of messages and internal payloads. So let's take a look at some of this in action. Now, if you remember, I talked about the initial scanning, and here we're looking at the quantity column on the order items, and you'll see what we've done here is that we've pulled out all the attributes, means, median, standard deviations, etc., and we've also created you a default potential expression that could be incorporated into your generation. If you have things like enumerations, in this case we've picked up that there are 4 status types: shipped, open, pending, and cancellation, and these can, as an initial state of your generation rule set, be carried through into the rule set itself. You can also override it and go into specific columns. Here we have a phone number. Now if I want to, I could use AI to populate that for me. So create a phone number using a US format, and that's created a function with the US number format. Now within the data painter itself, we have lots of different types of functions available, hundreds of different faker functions, calculation functions, etc. And we can also then make reference to the parameters that we can create. And also we can refer to other columns, which allows you to carry through consistency across different tables and use values from one table to drive the creation of data in another table column variation. Now within the rule set, you can also look up data from other sources to help you construct the content of your synthetic data. So in this particular example, we're actually creating some messages which look like this using our message creation technology. And within that, we have a rule set. Have a look at that rule set. Now, if we look at the rule set here, what you'll see is that we have what we call data sources, and you can add as many of these as you like, and you can go and get data from multiple different technologies to help you build up the data that you need. Obviously very useful for integration testing. Now, in this particular case here, we're actually building out our route and parties. The eventual message looks something like this, very straightforward, and we're transferring money between some random accounts within our OT bank environment. And here we also automatically create you the variables. Those variables contain lists of accounts, and we then use those within the rule set itself to actually transfer money between the different accounts. Now we have lots of different accelerators to help you build your synthetic data generation. Once you've identified the tables you're interested in, you can go to the rule set accelerators. There are various different ones that will pretty much do about 95% of what you need to do. So you can convert the rule set to a clone, which will extract existing data, reassign any keys, and create a new copy of it or multiple copies. You can also just have very simple ones to create a subset of data without changing the keys, create some upserts, etc. You can also just use AI to do most of the work for you, just run our assistant. What that will do is we'll use the descriptions that have been added into the details of the columns and tables, and also any scanned information, for example, some of the existing functions, standard deviations, enumerations, etc. You can also apply defaults, and this basically allows you to use previously applied functions, and after a while obviously you'll have lots of different generators and people will have lots of different functions that they need within the data, and all you have to do is pick those up, and then it will say, okay, based on what we've seen before, apply these in for you. So hopefully you can see that there's lots of different accelerators to quickly build you the right rule set to create the data that you need for your testing. So once you've created all your various data creation, data cloning, data subsetting, you organize them up into data pipelines. So let's have a look at the first one. And in this particular case, we're going to create some accounts, contacts, and some initial transactions. So you'll have a form for the user to submit the job, and that form is dynamic. So here we have drop downs, and depending on what you choose, you have a great deal of control in terms of how the form operates based on inputs. Here we can go and say, well, let's create 4 of them, 3, and we want an improving credit pattern, and we'll fire that job off, and that will then go off and create the data based on the information entered in the form. And that's finished, and we can go and look at the job. And there are the 4 contacts that we've created. So another important feature of job forms is that any form you create can be invoked using API requests, and we will automatically build those for you. So you can incorporate them into your REST frameworks. And if you have an automation framework, we can also embed some Java and some Java libraries automatically, so you can request the data from your automation frameworks. So let's carry on creating some more data. Now you'll see here that there are 2 ways to create data. One is using a scenario, and then the other one is to use a model. And what you can do is you can pick up the data generation, any enumerations, any form drop-downs, etc. will be expanded into a basic model. And here what we're doing is we are creating variations of different types of accounts. And for the most part, this model is automatically created from the work you've already done. And then we will create you, in effect, different test cases or data scenarios, and you have all sorts of different levels of coverage that you can set. So now when we run the job, we're going to use model variations. That will extract all the combinations of data that we want to create, creating you a much richer set of data at the beginning of your sprint. And that's created 30 separate scenarios. And there are 30 different contacts, accounts with initial transactions and characteristics created from that model. Now let's look at a few other techniques. So we can also use cloning, and the idea here is that we've converted one of the rule sets into a data clone, And in this case, we're allowed to give it a piece of SQL to choose the contacts and accounts. And in this case, what we're doing is we have a very small number of VIP with a very high allowed overdraft, and we'd like some more. So basically all we have to do is fill that in, fire that job off, and that will then go off and create us a new set of customers, accounts, and transactions with this characteristic, but with different sets of primary keys. We also have a different method where basically we can capture data. So here we're going to look at very specific, my favorite contacts, and we've actually pulled them into the product like so from our development system, a couple of contacts, some accounts, and transactions. Now this is in effect raw data, and you can just edit it to help you craft the data that you need by using our list editor. And then all you have to do is just execute that, and that say how many you want, and that will pick up that data and create you 6 copies of your templated data. You can override the data. For example, you may want to change the names and the IBAN numbers, etc. Now, you don't have to just deal with one database type at a time. You can connect to multiple databases, data sources, ERPs, etc. And you can also create messages and also read in messages. So here what we're going to do is just create ourselves a batch of random transfers between accounts, and we can just fire this job off from here, and that's finished. Let's go and have a look at the messages we've created, and here you can see created some random transactions to move data between accounts. Now let's do the reverse. We're going to actually read those JSON messages back in, and we're going to apply the content of the messages to our development database. And what we're doing is creating the underlying balance transfers that need to occur inside the database. So we're simulating the effect of being able to run the messages in and apply the required changes to the database. And that's finished. And again, let's just have a look at the back-end data that's been created. And here you can see the bank transactions that have been inserted into the database, which have been extracted from the JSON messages we created earlier. So now let's move on to a few other techniques to support your development and testing. Now, a good one is subsetting a database, and that's basically creating a cut down version of a database that is fully business intact. And in this particular example, I'm going to show you we're actually going to do a subset, i.e. make it smaller, and then that subsetted database, we're actually going to mask it as well. So you have a source, typically that's a production database. From that production database, we've already categorized the tables into reference, driving tables, and linking tables. And out of that, we create what we call a subset rule set. We then run our subset processing, which recursively goes up and down the relationships, pulling out reference data, pulling out transactional data for the associated criteria that we've used to subset that database. Once we've created that subset database, then we can run our masking engine, which will run through the data in place and remove any PII or commercially sensitive information. So here is our data pipeline, very straightforward. We have a subset and we have a mask. So let's go and look at the subset rule set. So what we have here is a list of the tables that we're going to be subsetting. We've set them as active like so. We've also categorized them up as reference, subset, or driving tables. You can have more than one driving table. In this case, we're going to be starting with a customer and pulling out everything associated with a specific customer or group of customers. And then we'll work our way up and down the relationships, and these relationships are defined here. We take a look at the ER diagram. We're going to start with the customers, work our way down through the warehouses, inventories, etc. Similarly with the contacts, accounts, bank transactions, and down into orders and items. And then we're also pulling in the reference data as well. If we look at the masking rule set, you will see we are masking some accounts. Here we're masking the IBAN. We go into that, we can see that we're looking up a list of, in this case, Belgian IBANs, but we're also turning on cross-referencing. So although we're randomly choosing an IBAN, we'll make sure that if it's already been masked before, we'll use the same IBAN. And if we work our way down through contacts, you'll see here we're using some of our standard masking functions, first name, last name, and here we're actually doing some aggregation of first name and last name. And if you go down to locations, for example, we're actually changing the addresses and cities and states like so. So let's fire this off. Now here's our dynamic form. We're going to truncate it. What we're actually doing is pulling some data out from the same database and creating a new schema OT2. We're actually only pulling one customer out, which is customer 1, which is quite a large customer. And then we're going to call our masking. And when we call the masking, we're going to create an audit report. So let's fire that off. So that has finished. Now let's go and look at the job. It's given a small report here. And let's look at the detailed reports. Look at the subset first. Now here you'll see basically a detailed description of how it traversed the database. It will keep going up and down recursively, finding the data. So if you have a circular relationship, it'll go around 2 or 3 times to make sure you haven't missed anything. And at the end, it tells you how much data you've actually pushed into your OT2 environment. Now let's look at the masking, and we'll look at the audit report. And you can see we've gone through the accounts here, and it's showing us the old and the new value. So similar Belgian IBAN numbers. And also we've changed the first name and last name. You can also see the emails have been mapped through to match with the first name and last name, and then so forth out to employees and locations. So we're now going to move on to a very useful feature, which is finding and allocating data to tests. So you can request it through a form or through APIs, and we're basically going to connect to our development database. Now, what we're feeding into this is obviously the textual data dictionary that we've created earlier, the entity relationships, and we are going to put in requests via forms or directly with SQL or using AI. We then construct the query, and we will go off and search for rows with those characteristics. We'll then allocate keys for either sole or team use, and then we'll also decide on how long those keys are held for. So let's go and have a look. So here is our find data activity. So type find data. Now there's a couple of different forms that have been created, and this is how your user would request the data. I'll start off with one of our more traditional forms. And what we've done is we've scanned the data, found any enumerations inside the data, like so, and those then become available within the form for you to search on. And you can also then adjust it to put in various different more sophisticated types of searches, greater than or equal to or contains, etc. So in this case, I'm going to pick up a VIP, checking I want to mail. How many? I want 2 of them. I'm going to allocate them as well. So I'm going to say use to VIP mails and fire this off. That's finished, and it's allocated a couple of accounts, 757 and 758, which I can now pick up and use. In the background, we keep track of all of these, and if we look at our reservations, we will see the accounts that have been allocated, and we have got the SQL that's been constructed from the form. I can also, when making a request, reserve the data for unique use, as in no one else can use that account ID. So in this case, let's just pick up a VIP. I'm going to call it Hughes VIP, and I'm going to assign it a unique lock. And if we fire that off, it will not use any of the values that have already been allocated to read-only requests. And that's 759. And if we go and look inside, you'll see this has been assigned to as a write 759, and it hasn't picked up any of the other keys that have been allocated to other tests. Now let's look at running this using AI rather than a very structured form. So here we've created a very simple form, which basically just has one block, which allows you to enter text. So in this case, I'm just going to look for gender of M and an account balance greater than 100 with an increasing credit score. And also I'm interested in the order and an order by account balance. So let's say this is now Hughes mail greater than 100, increasing credit score. And how many do I want? And let's get 2 of them. And we'll fire this off. And this will then take that request, pass it into the AI engine. So this has made a call out to the AI engine that has then constructed the SQL and run that against the backend database, looking for any joins. And then it has returned 750 and 767. And if we just take a look at the allocation list now, you can actually see in here the SQL that it has constructed, and it's actually done a pretty good job of working out that the current credit score is greater than the prior credit score, and also ordering it by the account balance. and then it has allocated 750 and 767 simply by entering text into the form to find the data that you need. So now we're going to take a look at how you can easily join your DB2 data with other data sources, whether that's ERPs, flat files, data lakes, other databases. And the way we do that is that we allow the user to enter textual input. That could be SQL, but nowadays they can just use AI to construct the SQL for them. We then bring in all the textual data dictionary that we built up, the entity relationships. We'll pass it to the LLM, which will construct the query, and then that gets passed into our Federated engine, which allows you to query data across multiple data sources. So let's see it in action. If you go to our query composer, at the top you'll see cross-platform query. In this case, we're going to join DB2 with Postgres. That's chosen the two sources, and we can see all the tables sitting underneath each one of them. We then go to our AI engine, and here what we're going to do is get me the DB2 products that match with the Postgres order items. We fire that off. We'll then pass that into the AI engine. That will look at the tables and columns and any relationships that we've tracked, also look at any descriptions, and it will then go off and construct the SQL query for us. So that's finished, and we can see a very nicely constructed piece of SQL there. And then if we execute that, we can see that's gone off and it's found any matching DB2 products that then match with the order items in our Postgres database. So the last thing we're going to do is look at our pipeline tool. Now this is a full RPA environment, which allows you to pretty much build any workflows you like. We can call out to any tools within your organization already. We can integrate with all sorts of existing products and environment management tools. Plus we can also obviously integrate with all of our data activities, which allow you to perform all of the clever stuff we've been showing you. This is pretty much a simple example where we're using it to prepare an environment. We're loading up some standard reference data. We're snapshotting it for comparison. We might want to do some subsetting to create other environments for other people and do some masking. We might want to clone some data, and we might want to run some validation. So let's take a look at a DB2 pipeline. You can see we've got lots of if statements here, and when we run, we've got drop downs like so to run a snapshot, compare database with a snapshot, restore the data from a snapshot, reset some bank transactions if you want to set everything back to zero for the bank transaction tables. Maybe you want to reset some internal sequences as well. And these are typical of the things you'd like to do when you're manipulating your environments for development and testing. Over on the left-hand side, you'll see all the various different RPA type activities that are available: assigning, looping, putting data in and out of databases, executing in parallel, moving files around, etc., etc. And when you do a run, you basically get all of the information sitting down here like so. And of course, all of these can be fired off using the normal job submission forms or via APIs. So there you go, a complete test data solution for DB2. If you'd like to give it a try, feel free to get in touch.